Good morning, everybody, and welcome to Osher at UCSD and Osher Lifelong Learning at UCSD. I'm Mavis Porter. I'm a member of the Curriculum Committee, and this morning we are beginning our series of special talks from Anthropocene. And right after I've done my brief introduction, I'm going to do two introductions this morning. I'm going to introduce Lindsay Hunter, who will tell you about Anthropocene, and then afterwards I will introduce the speaker, who is Charles Kennel. So anyway, I'm ready to introduce Lindsay, who will tell you about Anthropocene.
Hello, greetings and welcome. Carter welcomes you to our biennial master class with Osher Lifelong Learning Institute, and today's esteemed speaker, as has just been introduced, is Carter member Dr. Charles Kennel. I'm Lindsay Hunter, and I'm the Community Engagement and Advancement Director for CARTA, which is the Center for Academic Research and Training in Anthropocene. And because I am a paleoanthropologist, that gives me the training to both talk to you briefly about what that means, as well as the ability to pronounce both paleoanthropology and Anthropocene. And I will tell you that Anthropocene is basically fancy for human origins. And so our goal at CARTA is to explore the origins of the human phenomenon. And today we're actually starting not at the very beginning, but at the end, because this is where most histories start, is we start with ourselves and we look backwards to see where are our origins and where do we come from. And today, Dr. Kennel is going to give us a bit of a preview as to what that path is leading us down. And unfortunately, as you can probably guess, it's not the brightest. But we will be sharing with you a lot of information that we welcome you to explore with questions at the end of this segment, as well as we continue within our series. And you can always visit us at carta.anthropocene.org to learn more about the organization. And without further ado, I'm going to turn it back over to Mavis so that you can enjoy today's lecture.
As I said, I'm Mavis Porter. I'm a member of the Curriculum Committee, and I'd like to introduce Charles Kennel. And he is a distinguished professor, vice chancellor, and director emeritus at Scripps Institute of Oceanography. He was educated in astronomy and astrophysics at Harvard and Princeton. From 1994 to 1996, he was associate administrator at NASA and a leader of its Earth Science Satellite Program. He was the 9th director of Scripps Institution of Oceanography, serving from 1998 to 2006. The talk today will broadly trace communications between past and present human exploitation of the environment. That's an amazing statement. The coming crisis of the Anthropocene and what we humans can do to alleviate the coming crisis. Thank you very much.
Well, thank you very much. I trust and hope that you will forgive me the discourtesy of my not standing up before you, but I hope we'll be able to make it to work. I knew that this talk was about where human beings have come from, but I guess I'm going to start off by saying a few things about where I think we may be going. And so the first thing to do will be to advance the slides here. There we go. Okay, my talk today is entitled All Paths Lead to the Anthropocene Crisis. And I'm going to review for you 3 key moments in my professional life where I think from which you can see how our understanding has developed over the last 16 years. The first has to do with California's first climate change assessment in 2006. I was director of the Scripps Institution at that time, and as chairman of the California Council on Science and Technology, I followed the development of the assessments of California's climate crisis between about 2006 and 2012. So that will be the first part of my talk, and that will orient us all, I think, about what we may expect around here. The next phase in the development of the subject had to do with this understanding as a global phenomenon and as a global phenomenon of human civilization. And that to that end, I and a number of my colleagues from Scripps attended a major, if you will, workshop, a week-long study week that was convened by the Pontifical Academies of both Natural and Social Science, emphasizing that human civilization is causing the troubles that we're in. And that took place at the Vatican in 2014. And I will spend some time on what I think we learned and what we concluded at that workshop. And then finally, at the opening of this month, I attended via Zoom, thankfully, a workshop that I've attended for the last 15 years in Kyoto in Japan, in which we reviewed some of the distressing events in climate change that we have seen in the last few years and made a call for increased and integrated attempts at promoting the resilience of our societies. So let's start at the beginning. I think some of the people in this room will have been in Los Angeles during a smog event. Some others of you may have been in London when the same kinds of things happened, and you remember that visibility at midday was as shown in the picture. And California, to its great credit, the state government undertook to address this profound problem, and it founded the California Air Resources Board in 1967. Since that time, of course, we've made a great progress in curing. People still complain, of course, but we've made a great deal of progress in curing the smog problem, and there has been a level 1 stage alert in this century, which speaks to the success of the California Air Resources Board. And now, at the same time, what this did was made our state government and its agencies much more alert to the problems of the environment than in other states. And as part of that, the state government developed close relationships with the academic community. And it was good that that happened because climate change was coming along. And so our agencies established intimate working relationships with the climate scientists around the state, including Scripps. And my first involvement with this effort was as a board member of the original Climate Change Action Registry in 2001. I was the only academic on it at the time. And the idea was that at that time, people forecast that there would be serious regulations on carbon dioxide emissions, and that alert industries and organizations, universities, and so forth would like to register with the state and have certified their carbon emissions before, in fact, they're required to limit them. And so we set forth some standards for the registration of CO2 emissions at the turn of this century. And this was many, many years ahead of other states. In 2003, there was founded the California Climate Change Center, which is the first state-funded program to investigate the impacts of climate change on the state. And as an alert scripts director, I made sure that our scientists both participated and got funded by that. And by 2005, the state had formed a climate action team, an interagency group, that you could look at the names of the subjects that they included as groups that had to work on the environment at that time: agriculture, biodiversity, energy, forestry, land use, oceans, public health research, and so forth. Data operations and water. And so already by that time, the state had a very broad sense, this group at least, was able to inform the legislature and the administration of the very breadth of the impacts of climate change. And in about the same year, the Governor Schwarzenegger made an executive order which required that the state conform to the Kyoto protocols that had been enacted in 1997 in Kyoto. We'll get to Kyoto a bit later. But the idea was that we were supposed to bring our CO2 emissions to 80% below what we had in 1990 by the year 2050. And that is a convenient date that sticks in the mind of many policy planners, and you will see that arise again later in the talk. In 2006, the extraordinarily important event occurred, and that was the first formal climate change impact assessment for the state of California, Our Changing Climate, which identified and studied carefully the risks to California. And I'm proud to say that Scripps Oceanography led the way in many aspects of that assessment. But what was surprising to me, and it should still be surprising to you, seeing the later history of the subject, was that as soon as the legislature could get its arms around the impacts of climate change on California, they enacted the first legislation ever taken by any state to deal with climate change. And that was the Global Warming Solutions Act of AB 32, still a legendary name in my name. And so that it added to my conviction that if people only knew what was going on, they'd take action. That has not proven to be the case in the last 15 years. But it was the case here in California, and that set us as a state, as a university, if you will, and as an institution, set us well on the way ahead of our competitors. In 2008, there was an executive order that required periodic assessments every 3 years in the beginning. That proved to be the key to keeping us alert to the difficulties. And I will continue on to my discussion to the third California assessment in 2012, when I was chairman of the California Council on Science and Technology and had some role in the release of that report. So I've already made the point. Repeated assessment is the key. You don't know enough, and you haven't kept track of events enough to know exactly what is going on. But by examining the trends, you can make some more intelligent comments about what to do. So our first assessment, and the most important one, and the historically important one, was the first assessment in 2006, which I will spend most of my time on. There was another one in 2009, and the third one in 2012 focused on the wildfire issues, which unfortunately we in San Diego started off. But the first California climate change assessment took upon itself to compare the impacts on California of 3 different levels of climate change: low, medium, and high. We didn't know quite exactly how it would work out, so we took climate models that gave us a low impact, medium impact, and high, and tried to predict what would happen to let's see, it says the Sierra Nevada snowpack. That was the key issue for us. Sea level rise, heat wave days, drought, heat mortality, electricity demand, fire frequency, and forest yields. And as I pointed out, this was taken seriously by the state government. And there you can see Arnold Schwarzenegger with Tony Blair at an international meeting, along with the CEO of British Petroleum, and at the bottom claiming credit for California's leadership at the 2009 international meeting of the Intergovernmental Panel on Climate Change. So the key, as always, was follow the water. If some of you may have read some of the books of the California's iconic historian, Kevin Starr, passed on recently. And Starr's mantra, which I was fully aware of, was that California's history is written in water and not ink. Now, those of you who have seen the 1974 film Chinatown, Jack Nicholson and so forth, know that that is about the political struggles that were involved in bringing water to Southern California, bringing water to the San Fernando Valley from Tulare Lake, and making the Chandler family of the Los Angeles Times extremely wealthy. You may also, probably very few of us recall the construction of the Central Valley Project, but in which California constructed an aqueduct that brought Sierra Nevada water that had accumulated in Tulare Lake, brought it to the San Fernando Valley. And it made us the country's leading agriculture. We're the Ukraine of California, is the Ukraine, particularly in specialty commodities, the leading agricultural producer in the United States by dollar volume. But it wasn't always that way, and it's due to the enormous irrigation projects that we started during the Franklin Roosevelt era. So with that, I should just simply point, here is the Sierra Nevada. There's our changing climate. There are two maps of the snowfall that will be expected at the lower and higher emission ranges. And Scripps' main contribution to this was a study of climate change that predicted that by the end of this century, the snowpack in the Sierra Nevada at the end of winter would be down by 70 or 80%. And the problem was that it's a serious problem because 70% of our water in Los Angeles' water comes from the Sierra Nevada indirectly through this collection, through the deposit in the Sierra Nevada snows and then the aqueducts. Here in San Diego, we have two sources of water, both of which are threatened. One is from the north and one is from the east. This Colorado River. So we're slightly more resilient than Los Angeles, but we predicted that much of the snow cover that we depend on and our whole civilization depends on will likely be gone by the end of this century, by 2090. That had its effect. And I suspect, knowing the culture and history of the state and its involvement with large water projects, that was the instrumental observation that caused the legislation that the legislature enacted immediately after this report occurred. Now, the other problem, of course, is wildfires. It's a California problem. We all know about them. We learned early about them, actually, at least in this narrative. You remember both the 2003 and 2007 wildfires. It appeared that they would occur. At that time, we were afraid to occur every 4 years. But they took thousands of structures because they occurred in urban area. And our changing climate then took upon itself the report to try to estimate what the change in wildfire frequency in California would be over the coming century, the one that we now live in. And so they made a estimate of the wildfire risk relative to 1971 in 2085, about 100 years. How would it have changed over the proportion of this century? Now, what you see is two maps that come from different climate change models of that period. And we showed the two maps, of course, because there's always uncertainty and difference in agreement and problems between the models. And these were very seriously and consistently attacked by an organized denialist opposition at that time, who argued that the climate change models were not accurate enough to base any major public decisions on. That's the most charitable way to describe it. What these two maps show, the red shows where the probability of having a forest fire in that area is 4 times what it had been. And so you can look at the two maps, and they look about the same, don't they? One's a little bit more severe than the other, but the two maps both are consistent in where we expect major wildfires to occur at the end of this century. So the fire frequency will go up by about a factor 4. Now, most of those don't hit the news. I mean, they're all in urban areas. They're not all San Diego fires that take thousands of structures, and so they don't make the news, but our firefighting agencies are probably twice as busy as they had been when the report was being written. Now, another thing that came about was the state government understood that California itself was like a country. It's big enough to be a European country, and it has a number of very distinct climatic regions within itself, as you might understand just by driving east for 40 miles. But in any case, the state agencies had divided the state up into districts according to their responsibilities. So we have how the state conceived the regional distribution of water problems, the regional distribution of airshed problems, the climate regions, and so forth. And so we understood right away that a state assessment was needed because you had to know which regions, what the regions were, and you had to have agencies responsible for dealing with those regions. But at a deeper sense, it meant that the work that is done at the global level is rather broad and will not serve the needs of local regions. And so you have a further responsibility once the global assessment is made to take assessment of what it means for you and your people. And this was a big lesson for me. And this sent us on the path of looking at microclimates. And of course, we're a state that leads the world in specialty crops. And for these, microclimates really matter. And anyone who has visited a winery recently will know that the winery owner will tell you that. And so, and we have some even here now in San Diego County. And so geographical specificity and increasing the specificity of the predictions and forecasts was going to be an essential scientific advancement that we had to look after. So at the end of this period in 2012, when I looked at the 3 assessments, I had a fairly clear idea, we had a fairly clear idea of what the role of science would be in helping regions adapt to climate change. And the job was for science to provide the information, the knowledge, the climate models, the measurements, systematic measurements, enable adaptive management. You couldn't forecast with great certainty what's going to happen, and so you can't make decisions forever, but you can make decisions on the basis of ongoing evidence, and that's what we thought should be done. And so we should do it locale by locale, microclimates, county by county. We have, 57 counties in the state of California, and town by town. And town by town is important because it is the leaders of the towns and the cities that are on the front line of adaptation and have the power and the social understanding to make action possible in climate change. So that's where we were at 2012. So we also knew that, that climate change was a profound problem that affects global society, that has impacts on cultures and that are very different from ours, and has impacts on the very poorest. And we in California are really not very experienced in dealing with systemic poverty and how it will respond to the problems of climate change. And so to that end then, one of the, probably the most instrumental conference that I attended relative to my thinking about the global issues was convened by the joint academies, Pontifical Academies of Natural and Social Science, and it was co-chaired by colleagues of mine. Ramanathan from University of California, Scripps, who chaired the University of California Bending the Curve initiative and helped design the university's response to climate change. And my equally eminent colleague from Cambridge, Partha Dasgupta, who was very interested in, that he had spent his entire life on the economics of biodiversity collapse and finding a way to get government decision, if you will, people who decide on the basis of economics, to decide also in favor of saving rather than destroying biodiversity. And so the two traditions came together at this conference for the first time. Climate change on the one hand and eco-environmental devastation on the other. And we decided that ecological and social change, it was a social science meeting as well, they cannot be separated. And so it's a function of our global society that is producing, it is the nature of our global society that is also producing the nature of our global problems. And so I would now like to turn a little bit to that. My discussion will be far more abstract and far more about human values than you heard earlier. But having seen what we thought was in detail, somewhat detail what we thought was at stake in California, it will enable you to imagine that the same issues or the same kinds of issues will come up in the global context. So the meeting was held at one of the most beautiful places in Rome. Here's just a picture of the spot. I couldn't. The name of the conference or the workshop, this is a study week. It was called Sustainable Humanity, Sustainable Nature, and then the third part of it, as you might expect from the host, was our responsibility. So it focused on the social drivers of climatic and ecological change and how our society should cope with it. And it was at this conference that we all realized the importance of a word that had begun to be used by Paul Crutzen, whom I co-chaired a symposium in March for CARTA that honored the memory of Paul Crutzen. And Paul was a earth and environmental scientist, but he made the simple observation, along with lots of other people, that human beings had changed the face of the earth so much that if you were a geologist 1,000 years from now digging down, you would find a layer that corresponds to when we started to devastate our global environment. And that layer deserved a special name, the Anthropocene, a new geological era in which human activity at the global level is determining the nature of the geophysical and biological environment in which we all live. And so we came to grips with this concept first at a first conference at the Vatican on the California's Sierra Nevada problem, the problem of melting snows around the world and water availability to the cultures in Asia and Africa and the United States. And we came to, that conference was the fate of the mountain glaciers in the Anthropocene. And we came to grips with Paul's great concept at that point. And then the whole conference was involved with the question, what is the human responsibility for the global environment? Now, another way of saying it, Paul's statement was expressed in a slide that I found that I was giving in 2006 and 2007. And this, what this is a synthetic assembly of photographs of the Earth from the sky at night, showing the position of the city lights. And those are in white. There's burning of wildfires and oil and so forth in the yellow and so on. But in any case, it's a map as we do it at that time of the extent, geographical extent of the human domination of the landscape. And what we know already then was that in the last 50 years, before 2006, after 1956, we entered a new era in the 4.6 billion years of geological history. That also means that the Anthropocene and anthropogeny all occurring in this new era. And so, in some sense, we are inevitably part of the evolution of the planet as a whole. Now, at that time, the kinds of things that we knew were global warming, worldwide biodiversity collapse, habitat fragmentation, long droughts, ozone depletion, global air pollution, deforestation, desertification, retreating glaciers, disappearing polar ice, sea level rise. A pretty comprehensive description of a general ecological crisis, not a particular one. So clearly, it was clear that there were people far more vulnerable to climate change than in California, and people who were far less equipped to have early insight. And so one of the things that we concentrated upon was that the countries least responsible and least able to adapt will suffer the most. We have an ethical obligation to the other members of the human race around the world. Now, the other thing we knew was that at that time, and still now, there's the whole climate change policy arena is riven by conflict between the rich and the poor, and so that there's assertions of blame and responsibility, but few things that appeal to both sides of the development countries. However, perhaps the assessment assessments that prove so important in California can be welcomed on both sides. A potential mutuality of interest in the global knowledge action network for disaster management and adaptation. Perhaps we can cooperate on that. We can share views. And clearly there will be asymmetry in scale and financing and ethical responsibility, but both sides have an interest in dealing with the impacts of climate change and sharing their understanding of them. Now, at this point, I'm afraid I'm going to have to get somewhat abstract and relate to you some of the statements that this workshop we worked out amongst ourselves. They're rather abstract, but I think that this will give you a sense of the breadth of the understanding that we had, breadth of sense of crisis that we had. We all recognized that there were crises of poverty, exclusion, and the environment. The key point was right at the top. Humanity's relationship with nature is riddled with unaccounted for consequences. Here's the key statement. Socio-environmental processes, the social interactions that are leading to this compromise of the global environment, they are not self-correcting. They are no longer self-correcting, or we wouldn't be heading towards an Anthropocene crisis. It's an interaction that we've never dealt with before. And we're paying a high price for the growing gap between the rich and the poor. And it's also clear that to us that market forces alone, though essential, can't solve the intertwined crises of poverty, exclusion, and the environment. And this group in particular, in this environment, took upon itself to remark that unfair social structures become environmental obstacles. But the question is there hope? And in this statement, I think you see some, but you also see the two sides of the problem that were revealed to me, in their enormity at the Vatican Conference. Healthier, safer environment is possible. We can still do it. But, and here's two paragraphs important. The massive fossil fuel use at the heart of the global energy system deeply disrupts the Earth's climate and acidifies the world's oceans. The warming and associated extreme weather, which we're now beginning to see, will reach unprecedented levels in our children's lifetime. The Kyoto Conference of 2022 said they've reached unprecedented levels in our lifetime. And 40% of the world's poor who have a minimal role in generating the problem are likely to suffer the most. And through their suffering, perhaps present the unwritten codicil is that through their suffering they may present dangers to us in the advanced world. And the other part of it was that industrial scale, this is the ecological part, industrial scale agricultural practices are transforming landscapes around the world, disrupting ecosystems and threatening the diversity and diversity of the survival of species in the planetary scale. So paragraph 1 is Ramanathan's paragraph, and paragraph 2 is Partha Dasgupta's paragraph in my mind. And these paragraphs anticipate the notion that I will suggest to you, that we're all heading towards a comprehensive crisis at the end of this century, Anthropocene crisis. So at the end of the day, the critical unanswered question is, can we sustain a stable and prosperous and equitable society and a stable and supportive environment at the same time? Now, at the turn of the millennium, some colleagues of mine wrote books between the years 2001 and 2003 or so, these books came out by reputable colleagues. The End of Nature, The Future of Life, Collapse, Our Final Hour. The scientific community has been warning of this for a very long time. Now, to continue on with the, if you will, the lesson in ethics, the progress in climate, energy, equity, education, and conservation of living resources will be driven by values and faith more than data and predictive models. Data and predictive models are the working stock, if you will, of the solution, but the solution will not come until people, till the inspiration goes around the world. Now, many of you may remember my great colleague, Walter Monk, who died a few years ago at age 101. He was 96 when he came to this conference. And after we'd gone through and composed these statements, Walter made the following statement. This will require a miracle of love and unselfishness. So this is somewhere in the middle of the conference when the Pope came down to see what we were doing. And you could see Walter with his walker in the front. I don't know, I must be on the other side here someplace. But in any case, this was a memorable moment which stuck in, I guess, all our minds. We were all from different religious persuasions. We had the two people from India leading the conferences. They were not Catholic or Christians, but there was a convening of a global society, representatives of global society and ways of thought at this meeting. Now let's fast forward another 8 years to this year, when the Kyoto Forum on Science and Technology and Society convened its 14th meeting on regional action on climate change. And I attended that meeting. And at that time, the topic was we are beginning to see disasters, the types of disasters that had been predicted, and we're beginning to see interactions of them that threaten our security. A very simple one. One of the main ways to retire carbon dioxide is to grow forests. Plants retire carbon dioxide. They're good for the environment. But forest fires work against it. And so insecurity and management of impacts on climate change lead to further insecurity in your ability to cure the problem. And in that sense, we're finding that the disasters that we had once thought separate are now beginning to interact and need to be treated comprehensively. This is what I meant by Anthropocene crisis. Now, the Kyoto Forum on Science and Technology was held in the International Conference Center in Kyoto every year since about 2003. That is the conference center in which the Kyoto Protocol on Climate Change was signed in 1997. And it's been deeply supported by the government of Japan, and particularly by the long-lost, lamented Shinzo Abe. Here he is giving a talk to us. I first attended in 2006, and my NASA boss and I founded the adjunct group on regional action on climate change. Regional action, remember the lesson that we learned in California about regions, it applies to the globe. And so we founded a group on regional action on climate change, and we've held debates ever since that time. And here's a wordy slide. The we had a first session on regional action on climate change in 2009, and we wrote it the best that we can do as scientists is to write a declaration and hope that people listen. And so this was the declaration of the special session, the first one, on October 3rd of 2009. And there's a whole lot of words there, but there's 2 paragraphs I'd like to pick out. How should the tools and institutions deployed to assess global climate change be adapted to the needs of local decision makers in hundreds of regions around the world? We thought that decision makers that make decisions like the California government are local. There are thousands and thousands of them, many more than can be reached by the International Global Climate Initiative and negotiations. How there are millions of decision makers on the front line of adaptation, while there are thousands on the front lines of energy policy and mitigation of climate change. So what new social institution, technical and financial innovations are needed to cope with this side of the problem? And then the other idea that we had is in the next to last paragraph, the knowledge action networks that focus on specific regions and impacts, that is to say, an analog of California's way of doing things, can link the global science, technology, and policy communities to local initiatives. And there are social networks involving scientists and politicians and decision makers and finance people and so on. The social networks that connect the generation of knowledge to local action. So that was 2009. In the meantime, as we went forth in these meetings, we began to cope uniquely amongst global groups on the interaction between climate change and ecology. And in 2018, I got the idea that we were heading towards a comprehensive crisis. As personified by my 2 heroes at the Vatican, Ramanathan for climate, Partha Dasgupta for ecology. But if you talk to them, they think that their crisis is the one that's going to wipe out humanity. But which one is the more urgent? Which one should we go first? Go for first. Is it climate change? Is it ecology? Will they happen simultaneously? And then we can ask how human affairs, agriculture in particular, biodiversity in general, are affected by the climate disasters that we are not paying attention to. So in RAC 13 and 14, the last 2 years, we started focusing on the idea that there's going to be a comprehensive crisis. And the most important point is that this crisis is likely around 2090, when the demographers predict that will be the era of maximum global population in the world demographic transition that's now in process. It's been, in many societies, it's been seen that the population rises, reaches a maximum, and then declines. And the reasons for it are probably very mysterious, but they have to do with prosperity, the education of women, and a number of other factors that lead to a decline in the fertility of the population. So that maximum crisis is going to happen around 2090, according to the UN. And what it means is the number of humans at risk to these issues will be the largest at that point. And they will have the largest impact, collective impact, on the global ecological environmental problems at that time, regardless of what happens with climate change. And so whatever we are able to do the extreme climatic events will disrupt the ecologies and agriculture at their most vulnerable near the end of this century. That is the Anthropocene crisis. And what we said in the declaration that we are presently composing is that we already see potential mortal climate and public health risk unfolding today and interacting today. And we're not going to have, as a civilization, the luxury of dealing with them separately as we try to do today. So with this distinction in mind, that there will be climate change and there will be climate disasters, and the vulnerability of our civilization and our populations will be the largest at the time of peak population, then there are two dates on humanity's sustainability calendar. The first, which you hear all the time, is the term of art that has been assumed by advocates and diplomats. And that is the 2050, which is a convenient time. It's been set by the climate diplomacy community because in human judgment, it's probably the first time that we will be able to transform our economies enough that we can get to green economies, zero carbon emissions. And this is the goal that's been adopted by a number of countries, not mine, but obviously by the United Kingdom and so forth. And so 2050 is about, when you ask smart people how quickly can we transform our economy to cut out carbon emissions, 2050 comes to mind. That's the earliest that people think it could happen. But here's the important point. Zero carbon will not eliminate climate disasters. It will eliminate the increase in number and an increase in magnitude, or stabilize the problem, but it will not eliminate them, so they will continue. And the increasing vulnerability of the global environment to the predations of collective impacts of human society will progress. The second date, therefore, is set not by guesswork of diplomats, but by demographic forces. And that is about 2090, and the population will peak and start to decline. Now, the important point is that climate disasters, whatever we have been done beforehand by zero carbon to mitigate them, will still continue. And they will impact environments, ecologies, and agriculture when they are at their most vulnerable. And so the Anthropocene crisis then is that. Now, and so you should, when you start thinking about calculating the costs of building resilience to climate change, you really shouldn't think about 2050. It's not a full picture of the story, but you really should think about what will we have to cope with at the peak of the Anthropocene crisis in order to ease the impacts. And so we started thinking about, well, what will the energy demands of the Anthropocene at that time be? Energy demands. Now, you remember, we want to go to cleaner energy to mitigate climate change and go to zero carbon. So the interaction between what we do on adapting to climate change and what we do on mitigating climate change, they interact. So what energy resources will we really need to adapt agriculture and ecologies to the combination of extreme events and extreme vulnerability? So some of the things we might have to do. Maintain populations in otherwise lifeless regions, like today's empty quarter on the Arabian Peninsula. Here's one that comes to mind in the United States. How much energy are we going to have to spend on desalinating seawater to combat continental scale drought and desertification, as in the western US? How much energy will it have to spend just building aqueducts? That's the third one, long-distance freshwater transport to sustain that. And then finally, those of you who know that there are many complaints now about the energy cost of financial management computer systems. Just the costs of Bitcoin are enormous. How much energy will we spend on analyzing the climate, on computational networks? And then finally, there are people who think about what we should do about climate change after achieving zero carbon. It seems pretty far out, but nonetheless, you have to think about it. So what do you need to do? And so obviously, what you want to do is to continue to pull beyond zero carbon. You want to continue to pull CO2 out of the atmosphere. And the best way to do it, and the synthetic way to do it, is to grow things. Growing things retire carbon dioxide. Forests. You can design agriculture to be more carbon friendly. But there are also ideas that you should maybe filter the atmosphere and remove its carbon dioxide and attach it chemically to rocks and bury it under the ground, which is what we did when we made coal, or that the world did when the world made coal. Now, there's been a tentative study of direct air capture technologies. And they have one understandable but disappointing aspect. To make a material effect on a global quantity like the carbon dioxide concentration, you're going to require energy resources comparable to the present world energy production. That's how big this problem is. So, but at the same time, we see that our failure to adapt and to deal with the effects of climate change at that time are going to make very difficult our attempts to cure climate change by removing carbon from the atmosphere, or even achieving zero economy. So this is the interaction between adaptation and mitigation, the two terms of art in the community. And our declaration will say that to the next Conference of the Party meetings in Egypt, that much more attention should be paid to these, intellectual and financial attention should be paid to these issues. Now, I started off life as a physicist. And so here's something that I'm following. Planetary engineering, that is to say, geoengineering on a global scale, is going to require, whatever the technique, planetary scale resources, not national, planetary scale resources. Planetary scale resources to change the planet. And so one of the options, I think, before us is fusion energy, which has been on the back burner of people's thinking since the 1970s. And in this decade, the International Toroidal Experimental Reactor, ITER, will probably announce first fusion plasma in the 2024 era period. And that will cause a great flurry of excitement. There's a long way to go, but they also have not, I don't think that this technology will come to bear by 2050, but it may come to bear by 2090 if we set our minds on it. And the reason is that we don't know whether green energy technologies and conservation as a presently conceived, can carry the whole burden that we are facing. So the Anthropocene crisis might well be happy to have a nuclear fusion option to deal with the more extravagant energy expenditures required to both engineer resilience to climate disasters and to draw CO2 from the atmosphere. And so with that, it's not a very happy picture, but at the same time, it speaks of the success of the human species in transforming its environment to suit itself. And now we face, it's become so successful that we are victims of our own success as a species.